Good morning or good afternoon, depending on where you're calling from. My name is Charlotte, and I want to welcome you to today's webinar, The State of Stream Processing. Before we begin, we do have a couple of housekeeping items to go over. Everyone will be muted for the webinar, but please type any questions you may have as we go along into the Q&A panel, and we'll answer as many as we can at the end of the presentation. This session is being recorded, and it will be sent to everyone via email following the webinar. Now that we've taken care of that, I want to thank you all again for joining us today. Today's webinar will be presented by Dennis Duckworth and our guest speaker, Mike Gualtieri. Dennis is the Director of Technical Solutions at Hazelcast and has helped many companies in their adoption of various leading-edge data management technologies. Dennis is currently focused on bringing the benefits of real-time stream processing to Hazelcast customers and prospects. Dennis is joined today by our guest speaker, Mike Gualtieri. Mike is VP Principal Analyst at Forrester. Mike's research focuses on artificial intelligence technologies, platforms, and practices that enable technology professionals to deliver digital transformations that lead to prescient digital experiences and breakthrough operational efficiency. With that, I'm going to pass it off to you, Dennis, to get us started.
Well, thank you very much, Charlotte, and hello, everyone out there. It's my pleasure to be here to talk with you about the current state of stream processing and where we at Hazelcast think it's going, and to be joined by Mike Gualtieri from Forrester. Mike has extensive experience in this space. He's written several Forrester Waves or led the Forrester Wave projects for streaming analytics, and I'm really happy to have him here to provide his perspective and insights in this area. We already covered our housekeeping, so just to touch on the agenda, we'll start with Mike giving a rundown of how he sees the space and the need for fast data streaming platforms in the space, particularly stream processors. I'll be talking about Hazelcast's place in stream processing in the data management space. And then we'll have a little more fun. We'll open it up to an open discussion, really, with me and Mike talking about the various points about a stream processing platform and what's really needed, what's available out there, where things are going, our own experiences and insights in the industry. So with that, I'm going to turn it over to Mike. Mike, you can go ahead and start sharing.
All right. Thank you, Dennis. And hi, everyone. Let me just take a second here to share my slides. And Dennis, just checking with you that you can hear my audio fine.
Yes, I can.
Okay, very good. Okay, so again, thank you for being here. I'm happy to be here to talk about one of my favorite subjects and a topic that I've actually covered for 15 years here at Forrester, which is data streaming platforms, streaming analytics. In fact, the very first wave I did on this 15 years ago was actually, the title of it was Complex Event Processing, because at the time, there was sort of a wave of hedge funds, algorithmic trading needed to take that streaming data in at very low latency, do very low latency analytics on that. It's come a very long way at this point, and happy to talk to you today about some of the enterprise trends that we're seeing now. Now, we always like to give this sort of a business outcome emphasis and impact. And for streaming data platforms, it's all about enterprise decision-making. And that's because enterprises, really, if you think about it, like the core, the success of that enterprise is going to be based upon all of the decisions it makes every day. Now, back in the day, more of those decisions were made by people. And it was a slower time frame. And certainly some big decisions are still made by leaders. Should we acquire this company? Should we start this new product, sunset a product? And certainly employees still make many of these decisions as well. But more and more in this era, those decision logic is embedded in the applications that internet companies have, legacy companies have, all global corporations have. Right. And if you think of the portfolio of applications, there are hundreds of applications needed to run a global enterprise. And in each of those are decisions that get made. But now the data needed to make and automate those decisions exists in multiple platforms. What does that mean? That means we have to stream. We have to get the data in real time to the point where that has to make decisions. So ultimately, when it comes right down to it, data streaming analytics, data streaming platforms is really about capturing that data in real time to make those decisions. And we use the word decision liberally to also mean detect a pattern, to decide that that's a pattern of interest or an event of interest. So it's all about decision making, getting the data. And the time that companies have to decide, of course, is shrinking. You all know that. We all know that. And it's shrinking increasingly. So some of the applications for this is carrier assignments to meet a delivery in a world where different carriers may have different issues at a particular time. Real-time decisions about what will prevent a customer churn as they're being serviced either through chat. Deciding if an incoming transaction, where in a world where you might have thousands of transactions per second or tens of thousands is it fraudulent? Has to be decided right now, not collecting the data and then deciding tomorrow if that was a fraudulent transaction. Increasingly, in the world of IoT and edge computing, making those decisions right now, sort of the stuff that's decisions that have often been embedded, but making a loan based upon default and regulatory requirements, drone deciding what sort of level of crops in real time based upon the telemetry of the lighting and the ground conditions. So we could go on and on, right? For like just about every industry, every vertical, about use cases that require a decision to be made in real time. Now, the good news is that we have more data to make all of these decisions. The bad news is it's still fairly spread out across these applications, across these data sources, and many times third party. So we need to be able to capture that in real time to stream it from sources, get it to where it needs to be, and frequently that's multiple places. So that's sort of the business backdrop and the urgency of why more companies are investing in streaming data platforms, whether it's cloud, edge, and everywhere. And it's all about that data, because those data, again, they represent the physical events that's happening. And that's what you make the decisions on, those physical events that are happening. It also represents, though, the digital events, the clicks, the transactions. And of course, all of that represents what customers are doing, what's happening in the market. So all of that data, yeah, and you can call it streaming data, you can call it event data. I mean, every data that originates from in this manner is an event. It's streaming data, but whatever you call it, it normally originates in these silos, but it has to come together to make those decisions. And because of the time is slowing down, that's why, again, why streaming data platforms are needed. Now, I still get into conversations where people are asking, well, what do you mean by real time? Oh, we don't have a real time use case, because real time means, it just becomes infinitesimally smaller and smaller and smaller. But really, real time means business time, right? So in the case of algorithmic trading, that can be, some number of microseconds. But in the case of of an e-commerce application, it could be milliseconds. In the case of sort of drone footage, and it could be minutes, perhaps, or seconds. So real time really just means business time. But if you think about it, wherever that data originates, it all materializes in an instant to represent something. So the streaming use cases are vast across all data that originates. And the thing about that data is that it represents what's happening. So we need insights about what's happening, and we need to make those decisions. And at Forrester, we call those perishable insights. And here's a little framework that we use to help think about this. And you can see on the y-axis, there's this time to act, time to decide. And on the x-axis, there's this perishability of the insight, not the data. Don't misunderstand. I'm not saying that data goes stale. Sometimes it can, but actually historical data is critical for sort of aggregate insights and even for machine learning. So we're talking about perishable insights here. And of course, those insights come from the real-time data. And companies have invested a lot on the right side here, right, on these performance insights, business intelligence, tooling, and invested for many, many years. And increasingly so on the operational insights. But the biggest area of investment now, or at least the fastest growing, is the real-time insights that come from streaming applications for all the reasons I just stated. And I give you some examples of how it doesn't replace all decision-making here, insights, action, decision. But there's certainly a spectrum of need across these insights. So you can see, another example here. And I bet if you think about your business right now and you come down to some critical business process, you could draw this exact same chart probably a dozen times over your critical business processes, and you'd probably see gaps. Oh yeah, we do have some real-time decisions, or we can make them even faster if we could get data faster. And of course, because that time to decide is shrinking, this is where we start worrying about not just about what data stream we need, but we worry about the architecture of the platform that we're using, because, and I can't wait to get into the discussion later with Dennis, because we're going to talk about sort of the architectural characteristics to look for in a streaming data platform, and things like latency and scalability and other things like that are getting increasingly technically challenging because of the time to decide that's shrinking. And the other reality here is we can't re-architect everything for streaming data platforms, because most companies, whether it's a bank, insurance, and other companies, their application architecture was designed at a time when it was about reporting those slower insights. We can't eliminate that architecture easily or cost effectively or without risk, but we can use data streaming platforms to provide the connective tissue and the analytical tissue to connect all of those sources to analyze the data sources that they originate. So that's another thing we look for in data streaming platforms is how can we integrate that into existing architectures. Traditional databases are very fast at transactions, right? They're oriented towards that right transaction. Data warehouses are oriented towards a aggregate read, but they're not fast enough. Neither one of them is fast enough at the analytics or the data movement necessary to analyze from multiple, and that's why this data streaming category has arisen. So a little bit more formal definition is we say that a data streaming platform is a data platform that supports streaming workloads with equal vigor. Now, I could give a whole presentation on what those streaming workloads are, but it has to do with connecting to data, moving it, analyzing it in time or dimensional windows, which is often a foreign concept to many, and then also some arbitrary processing, but in real time. And of course, there's the enrichment, right? Because with any stream, it usually doesn't include everything necessary to analyze that data. And Dennis is going to talk about this, and Dennis and I are going to talk about this later. So, our view at Forrester, our architectural view, is that streaming capabilities are necessary to build any modern applications that have to leverage real-time transactions, real-time analytics, and the event streams. And if you think about one of the hottest trends, which is AI solutions and machine learning, that becomes yet another analytic. It's not the only one, but it's another analytical method that belongs in a stream, because real-time artificial intelligence is also real-time too, and increasingly being used to make those decisions. So with that as a backdrop, I'd now like to turn it back to you, Dennis. So I will stop my share. Thank you.
Great. Thank you very much, Mike. And that's one of the reasons I love having Mike participate in this for the industry expertise and experience he has. It's not just the vendor buzzwords and so forth. It's what he's hearing from real world users of this technology. So let me go ahead and share. And let me present. Okay. Can you all see that okay now? Great. Okay, so we're calling this section Powering the Real-Time Economy. And as Mike said, sometimes the nomenclature, the vocabulary gets a little screwy, but just to add further business context, McKinsey last year issued a report about 6 priorities for the CEOs. And the context was the turbulent times, the economic headwinds that they're facing, and what's really important to them in facing those from a business perspective. And to Mike's point, you see today, they were saying that only a fraction of what they call fresh data is being used. And fresh data is the key here, just like Mike was talking about with perishable insights. The data is what yields those insights. And if you let it go by long enough, you lose the power of those immediate insights. These CEOs are dealing with legacy technologies that just can't keep up with the current demands, need for new architectural elements. And looking forward to 2025, they're seeing even more needs for doing this. So they're anticipating that data processing will need to dramatically transform to be able to keep up with the reams of data that are coming in. You think of just what 5G in the telco space is enabling with the information from the IoT, the industrial Internet of Things, data coming off of sensors, even your own home, your smart home with your smart thermometers or thermostats and your smart refrigerator, and everything is smart these days, always wanted to talk with you and to give you data and providing data that could be useful to you in some way, providing some insight. So for Hazelcast, real time is about seizing the moment that you're getting the data, that you have the ability to take action, and you can take action. Simply knowing is not enough. And that's part of the problem we see with a lot of the technology stacks out there. It's all about putting data into a database and doing it quickly. What happens when it gets into that database? What happens? How long does it take for an analyst to see that, to be able to react to it? So we're seeing more and more in the world of machine learning and AI, the need and the ability to be able to act on that data as it's being streamed in. So we need to act while the window is open. And if you think about your own business, there are a lot of changes that could occur if you have that ability. So for example, what if you're a bank and you could take action while the customer is actually banking, whether they're in a branch or online with you or on the phone with one of your operators talking about a particular situation. When the customer's shopping, when they're there, wouldn't a coupon be a lot more effective if they get it while they're looking at the item that you have the coupon for instead of 2 weeks later? During a fraudulent event, if a credit card is being misused, it's great to catch it while it's happening. If you catch it after the fact, well, you're liable for that money. Before the process breaks with the IoT, as we're talking about, when travelers are en route there, a lot of people who were traveling on Southwest Airlines knows the trouble that they had with their systems, and we had a whole blog and webinar about that as well that you can take a look. But all of these things are taking advantage of fresh data, fresh events as they're happening, and being able to act upon them as that occurs. So the world is shifting to real-time economy. More and more people and more businesses are realizing that their competitive advantage is in that fresh data, in the streaming data that's coming in. And businesses can't succeed any longer just knowing what happened yesterday or last week and trying to take action on it then. They need to be able to react to the shifting business conditions and environment as they're happening. And so Hazelcast's vision is pretty simple in this case. It's to enable the world to act instantaneously on data everywhere, whether you're in a data center, in a processing plant, at a factory, in a store, at the edge, in a smart car, wherever it is, these decisions need to get faster. The actions need to be get faster because the data is getting faster. And we think that our technology provides that capability. To clear up some of the nomenclature and vernacular a little bit, we see stream processing and real-time data processing as basically equivalent. It talked about the streaming data coming in, which is real-time data. And as Mike said, real-time is really business time data, and it's different for each one. But we think as businesses get used to the ability to handle fresh data immediately as it's available, they will find the business use case for that and make use of it. We do not see stream processing as near real time or micro batch processing. Some solutions are out there and they'll talk about real time, but when you examine it, it's a situation I was talking about before where they're landing the data and then hoping something happens to it. Or if some of the process, even some of the stream processors, they don't do it in real time. They do collections of small batches and process it into small batches. We don't really consider that to be true stream processing. And to further differentiate where we think we fit into the overall spectrum of vendors out there, we see the fast data stores, whether they're fast databases or in-memory data caches, anything that has really fast ability to serve up data. Those include the in-memory stores that I mentioned. And then you have the newer stream processing engines. And each one does its task and is able to accomplish what it wants to do, but we are in the intersection of that. So we have the ability to hold contextual information, historical information like the fast data stores do. So if you're using an operational data store or a digital integration hub, that's kind of what a fast data store would be. And then on the other side, you have the ability to act on data as it's streaming through these stream processing engines. And we are, at Hazelcast, are unique in being able to provide both those capabilities to you. And to further explain kind of the stream processing state and where it is and where we think it's going, there are companies out there that provide these fast data stores. And it's great if you're just looking for a faster horse, as we say here. So you need to get data into the database faster. You need to get data out of the database faster. But the database tends to be pretty passive. It's receiving data, and then someone or something needs to act on it while it's in the database. Nothing wrong with that. There are lots of use cases for that. A lot of customers are using Hazelcast for that. Tends to be overkill, but that's one of the ways they're using it. And then we had the development of the stream processors who said, wait a minute, we need to be able to act on this data and do something with it right away. So you have the data pipes like Confluent with Kafka. You have Flink and Imrock as the processing engines with Decodable and so forth. So this is all great for taking action immediately, but what we'll find that is missing in this particular piece is what we had with the first case of this historical context. You're making decisions on action, but what are those decisions based on? It's typically in this category, it's based on the data itself, the event itself, not that data in the context of history. And so we think that the next step in the evolution is where we are, what we're offering currently, and the only vendor who's doing so is being able to provide that high value of providing the immediate action on data as it's streaming in historical context. So understanding a history of a credit card transaction and be able to know with high certainty whether the new charge is a fraudulent one or not, and being able to take action upon that. And so another way of looking at this, and I'll just build this out to save us some time. We have the ultra fast data stores and some of the typical players in that space. You have the stream processing engines and processors in that space. And we have this further elaboration and development that's going on where the stream processing is becoming more intelligent based on machine learning and AI operations. So being able to take a Python model, for example, for fraud detection, for sensor readings, for something, and having that model being applied as soon as the data comes in to that real-time data stream. So if you think about use cases, for the ultra-fast data store. You can get a great 360-degree view of a customer. This is like a digital integration hub or something where you collect a lot of data and can be able to react to that set of data very quickly. You have the stream processing, which is taking this adding into that a real-time data stream of events coming through so you can react to those events quickly. And then you have the machine learning by companies like Databricks and Cloudera and so on, being able to be a place where data scientists can build accurate models based on that historical data and be able to then apply those to that real-time data stream. And there are ways of solving this problem without Hazelcast. But what we have found in talking to customers, they tend to need to have components doing different things. So for example, if they want to use Flink, Flink has very limited contextual understanding in history. You can use RocksDB for keeping state in Flink, for example. But if you want to maintain a longer term data store for historical context, for contextual purposes, you need to add something like a Redis. And then when you're using Redis and Flink together, you may need some kind of configuration engine. So Zookeeper is a very common one to use. So suddenly you have 3 different clusters that you need to maintain. And anyone who's in the DevOps space realizes that the more components you have, the more your life becomes complex. You need to manage upgrades. You need to manage security updates. You need to manage just life cycle of each one of the applications. And then you have to worry about all of the networking and intercommunication between those, the APIs, and whether they play nicely together and what happens when one changes versions and the other one doesn't. And God help you if one of those clusters then fails, how do you fail them back? How do you fail everything down and bring it back up into a steady state that's working? Kubernetes helps somewhat in that area, but that depends on a lot of other technology, including the operators for Kubernetes. And so what we realized that is by having our stream processing capability, in addition to our historical context and our machine learning inferencing ability, we can simplify clusters dramatically. And for simplicity's sake, I just showed 3 node clusters here, but in many cases, the efficiency of Hazelcast means that we can even have smaller clusters than some of the other components that's part of that overall more complex situation. A little general information about Hazelcast. We've got employees in 21 countries. We have many of the global, or quite a few global 2000 customers, some of the largest banks in the world. I'll talk about some of those in a little while, some of the largest e-commerce companies out there, millions of cluster starts per month with Hazelcast. So we know a lot of people are getting value out of us. We have relationships with companies like IBM and Intel, and we've been growing quite quickly, especially over the last year, and now we're settling into to make sure that the world really is aware of what we can do as far as stream processing in addition to our historical context capabilities. And as far as use cases, just wanted to mention a few. And these are real world numbers. We have one company that's avoiding $100 million plus in losses due to real-time fraud detection. 400% improvement in an offer conversion for a particular customer that we'll talk about in a little while here. 20 times faster time to market. Just imagine some of your workflow if you could take a task that takes you from 2 months and take it down to 2 days. How much more productive could you be? How many more things could you do? How much better could you make those systems? And being able to support thousands of payments per second. So just to dive in a little bit more on one of these details, one of these use cases, because I find it quite interesting, is PNP Paribas. It's a bank that had a system in place for making use of its historical data. And what it wanted to be able to do is make offers to customers for loans. And so they had this idea of taking a look and seeing when they could figure out a customer needed a loan, and based on their loan history and their financial history and profile, be able to make a loan to them. The problem was that they were using an established system that took them basically a few days to figure out all of that information, to figure out the inside enough to be able to make that offer. And so someone would go to an ATM, for example, and try to make a withdrawal and not have enough money. and they would leave that bank frustrated and go off. And a few days later, they'd get a text or an email from PNB Paribas saying, oh, by the way, we noticed you needed some money. How about we provide you with a loan, a short-term loan or whatever it is. And they didn't have very much success with that. And so this was kind of the system that they had in place. And then when we were talking with them, we realized that we could, through our stream processing capability, make that a real-time, not a near real-time, but a real-time operation. So we added capability to PNB Paribas infrastructure that allowed them to make this loan offer while the customer had their card still in the ATM machine. So they went to get some money from the ATM machine. They were denied that, but they could get a text at that moment from PNB Paribas saying, oh, we realize you were looking for some money. How about a short-term offer? And this increased the redemption rate on that offer dramatically. And it was really a game changer for PNB Paribas. And the important thing about this, especially, is that it shows that it wasn't even a rip and replace. We could take advantage of a system that was already in place and make it better, make it faster, make it more profitable for the company by adding this real-time capability on top of what they were already doing before. So taking a situation that was okay, making it a lot better by using this real-time capability. And Hazelcast has several offerings. We have an open source version out there, and we have many customers or users of that open source out there. We have an enterprise version, and we have a recently launched GA version of our Veridian cloud service called Veridian Serverless, and I'll talk about that in a little while as well. So just to touch on some of the common use cases that we see, again, we have customers using us as a low latency, high performance data store. And it's great for being able to do these operational data stores, real-time digital integration hubs, things like that, exposure for liquidity in financial services companies. You take a step up and you start adding the stream processing capability, and suddenly you can then act and react to these real-time events, the fresh data coming through, and being able to make these real-time offers, do fraud detection more accurately and more quickly, do remote monitoring of systems and things like that. The next step in the evolution and where it's kind of state of the art is being able to take those capabilities and also combine it with machine learning, and we call it machine learning inferencing, for being able to have the intelligence of machine learning added into the algorithms and the decisioning that is being made, and being able to react to it much quicker than you can have if you're relying on data scientists to build new models and so forth. Being able to have these models in the system as part of the loop and being able to react quickly to them. So that's where we see our spectrum of customers, and more are learning, especially the more sophisticated ones are getting beyond stream processing and realizing the benefits that they can get by adding machine learning into that mix as well. And so we take a look at this area and at this whole market, and we see this stream processing platform with capabilities and certain components. And so at this point, what I would like to do is bring Mike back in, and we're going to start just talking through some of these based on his experiences, based on our experiences, and how they matter in the space, and why you should be paying attention to them, or what you should consider as we go through those. So let me take a look, see, we've got, let's see. So there've been a few questions. Thank you very much for submitting those questions already. First one, let me start off by asking Mike. So Mike, you've done that. You said 15 years ago you had that CEP, Forrester Wave, and recently it's been streaming analytics.
Yeah.
Can you talk kind of generally about some trends you've seen in that evolution? And I think you might be on cycle for doing a new one this coming year. What kind of changes you're anticipating factoring in as you go forward with that project?
Yeah, we'll do one later this year. Well, what generally remains the same is a lot of these architectural characteristics. I mean, because we're dealing with real-time insights and real-time data. there's a lot of architectural characteristics that we look at in the criteria when we evaluate this. So throughput, latency, low latency, the ability to detect patterns and low latency, but also high availability, which I prefer to call fault tolerance, because high availability is more than just saying, oh, we're on a cloud that runs 5 nines, right? Because even if the infrastructure doesn't go down, something else could go down. So fault tolerance, distributing across multiple data centers, so security. So there's some architectural features that are just important to data platforms in general and are particularly demanding of streaming. So that hasn't changed, but the expectations have changed about what it has to absolutely do in that. What has changed more so is the expectations of the type of processing that can occur in the platform. I mentioned CEP, but there's also just real-time data transformation pipelines that need to occur in real time to get a payload that you can then decide on. And the second thing is, and Dennis, you mentioned this a couple of times, the need for enrichment, the need to enrich that stream with historical data or other stateful data needed to actually make the real-time decision. So again, that adds another architectural complexity, because now you have to take stateful data and it has to be right there next to the stream to be able to process it. We've also seen a lot of there's vendors that come and go in any market. So we see a lot of new, whether it's a combination of startups or existing vendors that have new products. So yeah, it's become a very dynamic market and a very hot market. All the public cloud companies have various service solutions as well that can be combined to provide this capability, as well as independent vendors as well.
Awesome. Yeah, absolutely. You reinforce some of the points that we have seen, and one of the reasons that we developed our stream processing in the first place. A lot of companies know us as an in-memory data grid and low latency data store. And what we noticed was that drive coming through, and just like the evolution from complex event processing, some people will look at Kafka today, for example, and say, oh, isn't that just an enterprise service bus? And there's a lot of similarities in old applications and old solutions versus what they've become now. And it's more of an evolution than a revolution. But a lot of the same technologies, a lot of the same concepts are applicable. We just have to make sure, for example, when you're trying to run something in the cloud data really makes sense. Trying to take a legacy application from the past and running it in the cloud sometimes works, but it's usually never the best solution. It's something that was architected to work in the cloud from the start, as opposed to being shoehorned in and
and Dennis, you also mentioned about solutions, maybe an architectural solution that combine a multiple cluster type products and stuff. That brings complexity, as you pointed out. But there's also cluster sprawl. I mean, actually, I'm thinking, I don't know, maybe 5-10 years ago, people were kind of proud. It's like, oh, I've got a 10,000 node cluster. But actually, with kind of like sustainability and efficiency and cost, now it's more like, I'm doing this with only 7 nodes. Oh, you're doing it with 700. So it's kind of shifted there. And in fact, one of the key criteria that I have in the streaming wave, but my other waves as well, is this efficiency criteria as well, to look at, well, how efficient is this technology is too, because it can be the lowest of latency, it can scale, it can, but now it also has to have this other dimension of efficiency, which is a proxy, of course, for cost and resource utilization.
Yeah, that's an excellent point. And efficiency is one of those things. You're right. I've heard so many customers or prospects bragging about how many nodes they have in a cluster, and it's like, so it just makes your life miserable trying to manage these things. And that's one of the major drivers to fully managed cloud services is these companies don't have the expertise to be able to manage at that scale, and they don't want to. They want to be a bank. They want to be an e-commerce player. They don't want to be an IT vendor to themselves, a provider. So that's a great point. Let me see where. So we talked about stream processing in general. Some of the major players we see out there, Flink and Spark. Do you have any general comments about where you're seeing them? Why Flink is so popular, for example? Anything as far as your experience?
Well, I mean, so you have to. There's different types of workloads that you'd consider as streaming, right? There's the I'm going to call it continuous processing, but then there's the analytics, which is very stateful. So, the processing, it's kind of taking these multiple streams and then outputting it. It's kind of doing a transformation, a real-time transformation of that stream. Whereas analytics is very stateful, requires a whole different technology. So when we're evaluating different platforms, that's what we look at. And some of the open source, like you mentioned, Spark and Flink. Spark is a micro batch architecture. We already talked about that. Flink is sort of over the years, it's kind of gone up. It's gone down. I think it's on an up stage now, but its architecture is more of a real-time architecture. There's kind of a trend, and I wouldn't say it's just with the open source, but even with how you're doing things. People can think of batch processing actually as a stream if they wish, because a stream is just a batch process is just a stream that has a beginning and an end. Right. So there's kind of a trend too that's saying, gee, if I can adopt a streaming platform and it has all these architectural qualities that allow it to scale and do throughput, maybe I can actually just not have a batch environment over here, not have a stream environment over here, but just use my streaming environment for batch as well. So I think that's another, interesting architectural idea. It's not as much, the technology, but it's just an idea about how you can also use streaming platforms.
Yeah, that's quite interesting. I spent a lot of time in the database world, and when Kafka came out, they started positioning Kafka as, in effect, a database. And if you think about the way a database works, Kafka can, with its data pipe, basically represent all the different values of a database. It never seemed to take off the way they expected, and they just ended up being more of the universal data bus of the world in that respect.
Yeah, and there's a lot of confusion, I think, too. Just like when you mentioned Kafka, it's like Kafka is its core capability is to move data from point A to point B, which is an essential capability for streaming, right? But there's other types of pipes and ways to do that too. Like, actually, sometimes Kafka is too slow. And that's why, like a lot of, like if you think about CDC, change data capture, that's a technology that lives deep inside the database, that as soon as that database writes new data, boom, like something like Oracle Golden Gate, and other there's open source CDC stuff as well. So, depending upon the latency and other architectural concerns, Kafka is not always the solution. It probably has a place in most large enterprises, but it's not the only architectural way of getting data. But however you get the data, the point is to get it to a data streaming platform that can then enrich it and analyze that to automate decisions or update real-time dashboards, that sort of thing.
Yeah, that's a great point about Kafka perhaps not being fast enough in some cases, and we're seeing more and more potential use cases out there of working at the edge. Hazelcast can work with a very small footprint, and what we're seeing as a place for us to actually process sensor readings coming in, for example, from the edge sensors themselves before they get to Kafka. That gives you the ability to react to them quickly, and also to do some culling down of the data. So before you feed into Splunk, for example, and spend gobs and gobs of money
Yeah.
keeping all of these huge logs. You can only be storing the data that really makes sense, that's really useful.
Well, yeah, I mean, the perfect example of that is a temperature sensor
Mhm.
that, like in a refrigerator and all the Walmarts, it's like there's a freezer temperature sensor, which is, recording the temperature like a few times a second. But that's not what you're interested in. You're trying to make a decision. Does that need a repair? Does someone need to look at that? You're interested in the temperature change or a threshold. Right?
Exactly.
A lot of
Yep.
that can be pushed to the edge. So many examples of that.
Yeah, and that's where the intelligence of machine learning algorithms come in too, because you could have it hard coded. All right, if the temperature goes above 90 degrees, send me an alert. But what happens if you replace that equipment, for example, and it's no longer 90 degrees or 80 degrees, it's 50 degrees. So
Yes.
by having something that can learn and watch, as you say, taking a look at the period of time and figuring out what is an average temperature and then reacting to it when it goes outside of that average, that becomes a lot more valuable, and then be able to change that based on different different environmental conditions, things like that.
Yeah.
So this is great. We're touching on a bunch of these different topics that I had branched out here with and already went through several of the components. We started talking about high performance. One of the things I wanted to point out in this particular area is that there are benchmarks out there for people who want to look. There was one done by the Hasso-Plattner Institute at the University of Potsdam comparing Hazelcast with Flink and with Spark streaming. And so it's really interesting to see, and it touches on the efficiency. So how much more efficient Hazelcast is, in addition to being just faster in many of the use cases. So I'll encourage people to go out there. When you see the slides, you'll be able to click on this, or you just do a search on ESP Bench and you'll be able to find that. Scale obviously is always important. It seems like everyone has that kind of nailed down. We've learned the mistake of scale up, and everyone goes to distributed systems and scale out, especially with the new cloud architectures and Kubernetes and so forth. Any insights in that particular area, Mike?
Well, yeah, so that's because I deal with vendors all the time and evaluate things, and they're, the simple answer to the scale is always like, oh, well, we scale out. You just add more, we have linear scale. But actually, in certain situations, that's kind of true. It's just like however much you're taking in, you just add and you can but what if that streaming data is somehow related to each other? What if you have to enrich it? What if it has to do with some sort of universal state that's maintained? You can't just distribute those. Those are not stateless workloads. Some are, but more of the advanced ones are not stateless. So there's some sort of state, there's some historical state or enrichment that has to take place. That's tricky. That's much trickier to scale in those circumstances. Now, I used to do waves on in-memory data grids as well, and that sort of technology has always been used to maintain some real-time space for low latency performance, and that's very, very tricky to do whilst also being highly available, because you have to. So it's not just a matter of distributing it. That's related to other topics as well. So it's a lot more complicated.
Yeah, definitely complicated. All of these aspects that we're talking about have so many different degrees, and you could go down a rat hole very easily on any one of them. One thing that's top of mind for a lot of people these days is security. You read about breaches all the time, and I think all of the vendors have been doing a good job of taking security to the best level that they can. You still hear about issues like just earlier this month, Redis was the target for some malware, and I'm not dinging Redis in this particular case. It can be anything. But the point here is that Redis was being used in a way that it shouldn't be. Just like MongoDB in its early days, and still now, is one of the major targets for ransomware, because the people who are using it are not necessarily that savvy about security, so they don't change the default, or they don't, they keep the default admin password. And that's what happened in this case. Something Redis servers that are exposed that aren't necessarily supposed to be exposed. And what I see personally is that each one of these components, especially in a multi-component environment, may be extremely secure, but what happens in combination? The security doesn't get stronger. Sometimes, in fact, it gets weaker, because once you have a penetration of one of those components, it could become very easy to expose and to penetrate some of those other ones. So part of our simplicity message has the security wrapper to it too, of with our enterprise version, especially the security that you get with Hazelcast could be better than, even if those other point solutions are extremely secure. Have you seen anything? I mean, obviously, in talking to your customers, especially these larger companies, security is always one of the top things on their.
I mean, and that's why I kind of corrected myself when I first said high availability to fault tolerance.
Yeah.
Because I mean, they're both, they should be the same, but that's one of the key concerns with security, is that something can happen, and if it does happen, how can you recover from a security event? So so there's normal security about encryption, and then the other quick comment I'll make about security is there's also trade-offs in performance. Now all of a sudden, if you're encrypting and you're looking for things, now you're adding another, you're adding more latency to that as well. So when we measure those, sort of evaluate those sort of things, we look for knobs and dials to turn it up and turn it down based upon the requirements.
Yeah. Just like consistency with databases, you can have the most consistent, fully consistent, but you have the trade-off of performance. So eventual consistency was developed. And if you have tunable consistency, that's the best of both worlds. So we talked about business continuity a little bit, and you're exactly right. It's not expecting failure is not a way to plan your system. You need to be able to plan for that failure, and how can you recover, how quickly, how much data will be lost, looking for all of those different metrics when you're looking at solutions and making sure that they meet your business criteria or SLAs.
And Dennis, sometimes the failure isn't the hardware that it's running on, or the cloud it's running in, or the platform itself, but it could be the software developer's application, or a piece of code that's running in it, right? Could have a bug. Right. Most software does have bugs. When it has that bug, do you have to shut the whole thing down? Can you do a hot reload? That's what. So, and again, that's another aspect that we look for.
Yeah. That's when the DevOps guys and the SREs really earn their money. They're the ones getting those calls in the middle of the night and need to figure out how to put the pieces back together once Humpty Dumpty fell off the wall. Cloud services, I bring this up. A lot of companies, as I mentioned before, end up managing many more clusters than they want. And so look for expertise. And I just wanted to mention that we just GA'd our managed service Veridian serverless, and it's available out there for people to go and sign up and try. It's a pay-as-you-go model. It's a free tier, so you can get started and learn. And right now it's running on AWS, but we're looking at some of the other cloud vendors for that as well. And the idea is to let us, the Hazelcast experts, manage your cluster, your Hazelcast cluster for you. So you just load up your data, make use of it, point your applications to it. We take care of all the hard work for those companies who just don't want to manage it anymore. And I think, Mike, you've seen cloud services becoming a pretty popular thing out there. Is it getting a lot of acceptance from the clients that you're talking to?
Absolutely. I mean, because if you think about, the history of software, it's always abstraction, right? Where you have to worry less and less and less. And so then that's what the managed services are. So, I mean, if something underlying uses Kubernetes, that's great. But is the future of like managing clusters having to have Kubernetes expert? No, that should be pushed down and abstracted behind a managed service. So I think what the big trend is having a managed service, but not just in the public cloud, but in private clouds as well. So it's basically, it's seamless across any deployment, because that's what enterprises want. Ultimately they want choice where they can run this stuff.
Right. Yeah. And that's going to be a whole new episode on what do you call that? I hear people calling it multi-cloud, hybrid
know.
cloud.
I know.
There's a new firm trying to call it super cloud. It's like, okay,
Oh,
yeah.
okay. I haven't heard that one. I kind of like that one. Super cloud. I like
Yeah.
that. Okay,
Yeah,
let me think about that.
We'll watch for that. Anyway,
Yeah.
so just to kind of wrap this section up, we kind of took all of those parameters and put those into this chart and compared ourselves to a data pipeline out there, stream processors, and a couple of these super fast data caches or low latency data stores. And this was our scoring. I kept it anonymous, but if anyone out there is curious about how we rank or rate against a particular vendor, please let me know. And the one thing you'll notice here that we are missing is the message bus for Hazelcast. And one of the questions that we got was asking about how we can replace Redis and Kafka. So thank you, Maurizio, for that question. And just to let you know, right now, we don't have the ability, but we are evaluating having some type of lightweight message bus being added to be able to take some of the workload off, or to in some cases eliminate the need for something like a Kafka when you really don't need that capability. It's like Microsoft Word. How many of the features do you use in Microsoft Word? Not many. So do you really need all that bloatware out there? In some cases, just need kind of a simple message bus there. And as far as resources go, I just want to point out a few things. We've got our resources section on our website. We've got our blog, and we also have an upcoming conference going on in London. And this will be a hybrid event that will be in person and also streamed March 9th in London, as I mentioned. And just to kind of do a plug, I mentioned this ESP benchmark before, and one of the lead designer, Gunther Hess, will be part of the panel at that unconference talking about benchmarking of stream processors, including Hazelcast and Flink and Spark Streaming. So if you're in the London area, by all means, sign up to attend that live. There will also be a training session that's held live right before this event. And this conference itself will be streamed as well. So if you can't make it in person, definitely sign up to attend that from a streaming perspective. So we've had a few questions. I've run a little longer than I wanted. I apologize. We've got a couple minutes left, but I already touched on Maurizio's question. One question from someone else: is the streaming capability of Hazelcast the same as Jet, or do we use something else? No, Jet was our open source project that added stream processing to Hazelcast. And so if you go out and look at open source, you still have the Jet project out there in addition to Hazelcast for the low latency data store capability. Our commercial product incorporates everything into one platform, the Hazelcast platform, as does Viridian, our cloud service. So all of that is wrapped into one, and it's Jet, which is called out in the CSP benchmark, as well as the streaming capability. So with that, I think we are out of time. So Mike, thank you very much for the conversation.
Thank you, Dennis.
I really appreciate it. I look forward to doing this again. And Charla, why don't you take it over to close things out?
Great. Thanks so much. Thank you both, Dennis and Mike, for a great presentation. And thank you, everyone, for taking the time to join us for today's webinar. We will be sending out an email with a link to the recording and the resources shared in today's webinar. As Dennis mentioned, we are holding our real-time streaming processing unconference on March 9th. We invite you to join industry experts and your peers to discuss real-time analytic trends and ideas, also with some great networking opportunities. You can join us in person in London or virtually from anywhere in the world. Also, if you're interested in diving just a bit deeper into Hazelcast, join us for one of our monthly live demos. See the Hazelcast platform in action. It's led by a senior solution architect from Hazelcast, and it's offered in multiple time zones for your convenience. Also, we are having our next upcoming webinar, how real-time responsiveness fits into your IT architecture. That's going to be on March 16th, so we invite you to join that as well. I've added the links to each of these in the chat window, or you can find our events, webinars, and more on our website at www.hazelcast.com. Again, we want to thank you for taking the time out of your busy days to join us for this webinar. And again, thank you both, Dennis and Mike, for such a great discussion and presentation. And we hope everybody has a great day.